All right, so today we're going to be looking at some word problems that have to do with rational equations. I'm going to go through it pretty slowly so that hopefully it makes it a tiny bit easier. It is kind of hard, so don't worry if you're still not feeling confident after one lesson. I'm only doing 2 examples today, and then tomorrow I can help you guys out with the assignment too. Okay, so if you're not printing out the notes, I would take a minute to pause this and write down the problem so you have it. The other thing you could do is just watch the video, and then when you go to work on an assignment on your own, pull up the completed version of the notes that I'm going to post. So either way is fine. Okay, but always with word problems, we want to start by thinking about like what we're actually trying to find and what the information they gave us is. So here I gave you some helpful formulas that I'll show you why we need them after we read the problem. So here's a few things we're going to need to know. So the 3 kinds of measurements are the 3 units that we're given are going to be either distance, rate, or time. So the first important thing we're given, 2 miles upstream and 2 miles downstream. Okay, so miles is a unit of distance. So that information is going to go in this. So upstream, downstream. Okay, then they tell me a total of 5 hours. Well, hours is time. Okay, now if I look here, we have upstream, we have downstream. I didn't make a column for total, so I'm just going to put over here that the total time is going to be 5 hours. Okay, now here's where it's going to start to get a little bit tricky. In still water, the kayaker can travel at an average speed of 2 miles per hour. Okay, miles per hour is a way of measuring rate. Okay, so I know that for both of these rates, it's going to have something to do with 2. Okay, but going upstream and going downstream are not going to be going at the same rate. Okay, so I'm going to pause there for a second. Let's just read the rest of the problem. The actual question is, what is the average speed of the current of this river? So that is my unknown. What is the speed of the current? So that's also going to have something to do with rate, because rate and speed are used in the same way in this problem. I didn't mean to write that, sorry. Speed of the current. So I'm going to use x to represent the speed of the current. Now, I have to think, okay, when I'm going upstream, am I going to be going slower or faster? Okay, going upstream, the current is working against us. So upstream is going against. So that's going to be slower. Downstream is going with the current, so that's going to be faster. So that means that the way that's going to affect the rate that I'm traveling in the kayak is that this rate is going to be the speed I can usually go minus the speed of the current. When I'm going downstream, the current's making me go faster, so it's the rate I can go by myself plus the speed of the current. Okay, now this is where the formulas I put up here are going to come in handy. So if you look, the part of our chart that we haven't filled out yet is time. Sorry, I'm just going back to fix this. So time. So I'm going to look at the formula that has the t by itself, which is this one. Oh my God. Okay, so here I have the t by itself, so this is the formula I'm going to be using to help me with the time. I'm going to take what I wrote for distance, and I'm going to divide it by what I wrote for rate, because that's this formula that I just highlighted, okay? Distance over rate equals time. Okay, so I'm just going to take what I wrote for the rate and what divided by what I wrote for distance. Rate divided by distance. Okay, now I have to look at the information I have and figure out what can I use to actually make an equation. Okay, so really there's three pieces of information that for each part, right? There's upstream, downstream, and total, right? So for distance, I already know the upstream, I already know the downstream, and I already know the total. So there's nothing I can do to solve for a variable if I use that as an equation. For rate, we know upstream and we know downstream, but we have no information to tell us what the total is. But if we look here for time, I do have three pieces of information. I have the amount of time it takes to go upstream, I have the amount of time it takes to go downstream, and I have the total. So what I'm going to do next is I'm going to make an equation that says the time, no, hold on, sorry. Okay. The time upstream plus the time downstream equals the total time. So let's look at our chart. The time upstream is 2 divided by 2 minus x. The time downstream is 2 divided by 2 plus x. And my total time is 5. Okay, now the first thing I'm going to do, so at this point, you guys, this is what we did in the notes 2 days ago. So the only new thing we're learning with word problems is how to get from the word problem to the point where you can set up this equation correctly. Okay, so what I'm going to do now is not new information. I already showed you this in the other video. So if you are stuck here, then you're going to want to go back and watch the one from Tuesday. Okay, so the first thing I'm going to do for this one is just put a 1 underneath the 5 to make it look like a fraction. And then if you remember the way I kind of thought about it the other day, I'm looking at how many different denominators do I have. So I have a 2 minus x here and a 2 plus x here. And 1 is not going to change the value of anything, so I don't need to multiply by 1. If you put times 1 on yours, you'll get the right answer anyway. So my least common denominator is going to take 2 minus x and multiply it times 2 plus x. Okay, so now I'm going to take every single term and I'm going to multiply it by my least common denominator. every single one by 2 minus x times 2 plus x. Now I'm looking for what can I cancel out, okay? So here I can cancel out 2 plus x, 2 plus x. Here I can, oops, sorry, that should be 2 minus x and 2 minus x. This is plus, and this one I can't cancel anything out. So now I'm going to write everything I have left. My first fraction, I'm left with a 2 and a 2 plus x. This one I'm left with 2 and 2 minus x. And this one, I have 5 times 2 plus x times 2 minus x. Okay. On this side, on the right side, you can distribute the 5 first. For me, it's going to be easier to do double distribution here first because those are conjugate binomials. So I already know that that's going to be 4 minus x squared because the middle terms are going to cancel out. You can write that all out for yourself if you want to. This is going to be 4 plus 2x, and this is going to be 4 minus 2x. So on this side, these are going to be canceling. So I'm left with 8. On this side, I'm going to have 20 minus 5x squared. Okay, now I don't have 3 terms, so I'm not going to use the diamond. This is actually going to be a tiny bit simpler. I'm going to just get the x by itself. Okay, so I'm going to subtract 20 from both sides. So it's going to give me negative 12 equals negative 5x squared. And then divide both sides by negative 5. So I have x squared equals a negative divided by negative is a positive, so it's going to be positive 12 over 5. And then the opposite of squaring is doing a square root. So at this point, you could put in your calculator the square root of 12 divided by the square root of 5, and you're going to get something pretty close to 1.5. Okay, so now we have to think, what does this mean in the context of the problem? This means that the average speed of the river is approximately 1.5 miles per hour. Okay, so I know it's kind of a lot, but just remember the hardest part is setting up the equation, okay? The next one's going to be different from this one because there's different types of problems that you might have to use rational expressions for. So I'm going to do the best I can with the next one. It's not quite as straightforward because we can't use the same table that we did. And the reason is this one we're not talking about distance. Okay, we're talking about how quickly someone can weed a garden. So let's look at the important information and highlight it first. So we have, Jesse can weed a garden in about 30 minutes. Okay. When Norton helps her, they can weed the same garden, so that's the two of them together, in about 20 minutes. Norton wants to know how long it would take him to weed the garden if he worked by himself. Okay, so my unknown here is how long will it take Norton? himself. Okay, so for the rate for this one, people want to put 30 minutes because minutes measures time, right? But rate is not, like for example, in the last problem, the way we were measuring rate is in miles per hour. This one, we're not talking about miles. We're talking about the number of gardens per, and the number of minutes. Okay, so rate is always one thing divided by another thing. In the problem before, it was miles per hour, miles divided by hours. In this one, it's the number of gardens over the number of minutes. So Jesse can weed 1 garden in 30 minutes. So Jesse's rate is 1 over 30. 1 garden in 30 minutes, okay? Norton's rate is what we don't know. So he's going to be 1 over x, okay? Now, we're not ready yet. See right here, it says rate times time, okay? For time, we're going to use the information they gave us about the time it takes them to complete the garden together, which is 20. Okay. And then that equals, because we have to have an equation, we're solving for a variable, the total completed job. So this one is always going to be 1. The total jobs is always 1. They're working together to complete 1 job. Okay? Now, that's the hard part. The next part is not so bad. I'm going to take these 2 fractions that I wrote and I'm going to put them over 1, or these 2 whole numbers that I wrote, excuse me, and I'm going to write them over 1. So then for multiplying fractions, we do top times top and bottom times bottom. So this is going to be 20 over x plus 20 over 30 equals 1. Okay, this next part is optional, but I do notice that 20 and 30 are both multiples of 10, so I can simplify that to 2/3. If you don't, you're still going to get the same answer, you're just going to have some bigger numbers to work with. Okay, now what's our LCD? Remember, this is really a 1 over 1. So I have 2 different denominators here. I have x and I have 3. Oops, sorry, I should have done that one in a different color. Because they're different. Which means my least common denominator is going to be 3 times x. So I'm going to take that common denominator and multiply it by each one. That's a times 3 times x. Okay, so now we have to look for what's going to cancel out. Hopefully by this part, you're kind of getting used to what's coming up now because this is what we've been doing. So So these x's cancel, these 3's cancel, and over there, nothing's going to cancel. So my next step, I have 3 times 20 plus 2 times x equals 3 times x. Okay, now I have to get x by itself. We don't have any x squareds in this one, so it's not going to be as much work. Here I'm going to subtract 2x from both sides. So I have 3 times 20 equals 1x, which means x equals 60. Okay, now remember, this means something in the context of our problem, so we do need to write the actual answer, okay? Which is, it takes, I think we're doing Norton, right? Who's doing this? Norton. It takes Norton 60 minutes to weed the garden alone. Okay, so that's it for the notes for today, you guys. Again, I would really suggest going back and watching the video again and actually like trying the little questions that I put in there for you, because all of that stuff I do so that you can learn. So if you're not utilizing it, then it's not going to be very beneficial to you. All right. We will put up a worksheet. I don't remember if we're going to give you a worksheet in addition to the notes today. So just check out Google Classroom if there's one assignment or 2. All right, have a good rest of your day, you guys.